As a music producer or someone that has a lot of MP3 files or audio files, sometimes the collection becomes very large and hard to find things. So I built this app. It's a free and open source app to manage my files and my tracks. It has normal search features like you will find in the normal application, but it also uses AI to do a lot of things. So for example, I can search for metadata, but I can also search for a specific vibe, optimistic mood, for example, or for specific sounds, like I want a higher to 8. And so if I click here, you will hear that it has an 8 to 8. Let's go over the features. So here you can see there is a lot of filters. This is the main list of tracks, and BPM's keys are extracted automatically. The metadata from the track is downloaded from online if possible, or extracted from the MP3 file. It detects the key automatically, it detects BPM, loudness, it extracts a description, AI description of the track, and the main genre, the mood, the instruments, some emotive file, basically scoring of different dimensions, if it's music or it's non-music, the genre, and if it contains vocal or not. You can also save searches, export as a playlist, find similar songs. So for example, let's look at only the songs that are in my that I made with Suno. I use Don Spiral as my username in Suno, and these are the ones that match 808. But if I remove this, as you see, it's super fast. These are all my tracks, and I can add a search by genre, only the rock ones, filter by playlist if I want, filter by key. Now I don't have a rock in C major or in C major or minor. I can filter by BPM. So for example, if I want a very fast track, I can filter by tracks that have vocals or just instrumentals. And I can filter out the non-music one. If I have audiobooks and other stuff in my collection, it will filter this out. The other things I can do is show all this data in a different way. So I can show this in a map, for example. This is my whole collection, and this is a map of my songs by acoustic similarity. So songs that sound similar are close by. So for example, both of these are rock. Let's look at the just mine so I can show you something. So for example, these two are rock heavy metal and they're close by enough. And this is also rock heavy metal. The other things you can get is a spectrogram of your song. So basically this shows you the different frequency and different part of time of the song. So here there is a lot of bass, for example. Here there is a break. It can be useful for that. You can find similar songs. So songs that sound similar to this checkmate isn't piece that I made. You can color this in different ways. So this is by genre, but you can use the Camelot wheel, which is the DJ way to call the circle of fifths. So this is basically coloring same tracks if they have the same scale, and you can color them by BPM. You can use different projection. PCA is much faster, but it doesn't do as good job of organizing your tracks. EMAP will actually take a few seconds to compute the first time. and then it's cached, so it's very fast. You can look for duplicates. It's super fast once you do the initial analysis. So this is duplicates on 2000 tracks by acoustic similarity. So I know that I have two perfect copies of this, but in this case they have probably slightly different encodings or different remixes. All of this is done by doing machine learning analysis of the songs. So there is an analysis pass that you need to run first. Now it will take sometimes it takes 1 hour for 2000 songs on my computer, which is an Apple M3 Ultra. But on lower machines it can take more time. The other things you can do is, for example, let's go back and compare my Suno songs to my wall collection. So you can see here the difference in BPM distribution, the keys used, the mood profile, trends, vocal character. This is useful if you're basically trying to make song on a specific genre and you have reference tracks and you want to compare your reference tracks with your actual tracks. The other things you can do, let's pick up one of my own songs, not to the AI generated. So let's sample this one. As you see, it detected the electronic trance. Let me try with a smaller song and I fix the bug before you actually get the binary. Okay, this is a smaller version of the same songs. So the songs we had before is like 6 minutes and probably the maximum is 5 minutes. And so it can answer questions, and after the first time it's very fast. What's the genre of this? As you see, it's super fast after the first time. Here you configure how this works. You can add different directories where it looks for tracks, and then you click scan and it will look for changes. It will automatically detect changes on startup. And here you select where to put the machine learning models. It's 6.3 gigabytes of data, so you can put it on external drive. Then you click on manage models and download neural models, and it will download them the first time you run it. You can decide if you want to automatically enrich the songs with metadata from MusicBrainz, an online service. And this is it. It normally writes a JSON file close to your MP3, so the next time you actually add the directory, it doesn't have to do a full analyze scan again. This is open source, as I said, and it's available on GitHub right now. It's still very early, it's a developer preview, but you can download it for Mac and test it. And the new versions will actually be on Windows as well, and probably Linux, once it's more stable and more powerful. There are some other features like the ability to have playlists to save searches, but they are minor.